Here in our Unit 5 Reteach, we're going to be focusing primarily on Part 1, which is about similar figures. And what similar figures are similar figures are two different shapes that have to have the same or congruent angles. And when they have congruent angles, similar figures have what we call our proportional sides. And what this means is that they have to be scaled by the same scale factor. So that's a lot to kind of break down. Those three big words in new academic language that maybe we're not familiar with yet. Well, congruent, what that means is it's a fancy word for the same. And so when we talk about congruent in mathematics, we usually use congruent to mean the same. So for example, if I'm looking at these two triangles over here. So when I look at those two triangles over there, what you will see is that, like, for example, at angle C, we can see that angle C and angle F are kind of skinny. And when we look at those 2 points, what we will see is that those angles are actually the same. So we put little rings around them. Now, will C be the same as E? Probably not. And that's the case and this over here. So what we're going to do is we're going to shift that and we're going to add on now 2 little rings. What this tells me is that we have 2 different angles here. So when we have one ring, that's one angle. When we add on another ring, that completely changes the angle size. But why do we use 2 different rings? Well, we can see that B and E will end up having the same angle. Additionally, we will also have A and D, which also have congruent angles. So there are 3 sets of congruent angles, and we need to know this for later on because we're going to be talking about something called angle-angle criterion, which allows us to know how many angles do we need. Well, angle stands for 2 angles. We need to know that 2 angles are congruent for them to be similar figures. With that said, how can I tell when we have what's called a proportional relationship? A proportional relationship tells us whether these shapes are the same size. So if I talk about like 5 to 10. So from like 5 to 10, what I can see is that when we have that proportionality, it goes from 5 to 10. How many times larger is that? Well, what we will see that is 2 times as large. So we can see that proportionality or that scale factor is 2. And we're going to be talking about this in the next part. What we just described there, when that shape gets larger, is what we call as an enlargement. So when that shape gets from smaller to bigger, we call that an enlargement. And how we are able to find out our scale factor is we take our scaled length, so this is your scaled, and we divide it by the original. So that would be 18 divided by 6. Well, 18 divided by 6, I know that as 3. So I know that my scale factor here is 3 times as large. I can also tell that by seeing how 6 goes to 18. And I know that 6 times 3 gives me 18. Now, it gets a little bit trickier when we start to talk about things like reductions. Reductions means that your shape goes from bigger to smaller. So this is your scaled. Or sorry, let's rewrite that. That's not your scaled. That is your original. And here is my scaled. So we're going from our original to our scaled. And what I can see here, it goes from 12 to 6. Now, what a lot of people initially think is, oh, that's 2 times as large, right? 12 is 2 times as large to 6, right? But since we are reducing, or that value is getting smaller, well, remember our fraction is going to be 6 over 12. Well, what I know about 6 over 12 is that doesn't make 2. That actually makes 1/2. So when we have a reduction is a fraction traditionally, or a number that is less than 1 but greater than 0. While an enlargement is going to be a number that's bigger than 1, or like 2, 3, 4. You can even go up to 1 million if you really wanted to with an enlargement. So why do we need to know what a scale factor is? Well, it helps us scale our shapes. If you've ever heard about something called like a blueprint, or if you think about a model home or anything like that, those are usually small, compact places that they use to help create something that's a lot bigger. Buildings don't have to have plans around them. They have to have ideas, and they're not just going to draw out a complete model, because that would be a waste of materials. So oftentimes they have to have a scale factor of some sort. So in this case, what we're going to do is we're going to create our own scale factor and draw out our own shape. So we're going to have the original shape of 0, 0, which is going to be at what's called the origin. And we're going to label that as S. We also have -4, 0, so I move 4 spots to the left. Oops. And I make a point there. I call that T now. So I have S and T. And finally, I have -8, -8. Now, -8, -8 is going to be a little bit outside of my range, but that's okay. So if that's 4, that's 7. Now we're going to 8, going down a little bit farther, and down here. So what I will see is that this shape over here, we'll go down 1, 2, 3, 4, 5, 6, 7, 8, right down over here. And that final point over there would be my V. So it's a little bit off our grid, but we're mathematicians, we get through it. So all we do is connect our dots, and voila, now we have a triangle. So now that we have our triangle, what we have to do is be able to apply our scale factor. So by applying our scale factor, what that looks like is we need to actually multiply. In both cases, we could either multiply like before, we could multiply by 2, or we can multiply by a half. And that gave us our value. So that's what we're going to exactly do. If we see that we have a scale factor of a half, make a prediction. Do you think that it's going to be an enlargement or a reduction? Here, what we will see is that it's going to be a reduction. And since it's a reduction, that's going to be the value of 1/2. We're going to multiply by 1/2 to each of these values. So not just the x value, but also the y value. Well, what's really nice about 0, 0, well, what's anything times 0? 0. I know, a little bit boring, but hey, it's going to spice up really quick here because we got -4. -4 times 1/2, that gives me a -2. And 0 times 1/2, well, that's good, our good old friend 0 again. Now we're going to take half of -8. Half of -8 is -4. And half of -8 again is also going to be a -4. So these are going to be my new points, and I'm going to use a different color to kind of help us show the different size. And what you're going to notice are these little ticks right here, or these apostrophes. So these apostrophes here are what we call our primes. And no, I am not talking about Logan or Jake Paul or KSI when we talk about prime energy drinks. What we're talking about here is primes when we're looking at a new shape. So prime in math just means new. And so we're going to be describing this new shape, and what we'll notice is that the first point actually stays on top, and we're going to relabel it with our S prime. And so you can just draw a new dot on top, and then if you're using pencil, it's not going to look any different. And that's a-okay. But our T is going to be in a new spot. So if we move 2 spots to the left over here, I'm going to have a new spot right over here, and that's going to become my T prime. Then down below, what we will see is at -4, -4, we move 1, 2, 3, 4, 1, 2, 3, 4. And we will get our point right over here of V prime. So like we do, as we always, mathematicians connect their dots. I get a little cheating on my iPad to make it all nice and straight. But look at that. I made a shape that ended up being a little bit smaller, specifically half as small. So that's going to be it for part 1. What we will see is we have talked about now, first, our scaled factors. We talked about similar figures and how we can create a similar figure using a process called dilations. Hopefully this helps. If you are feeling like you're confident, try doing some little bit of extra practice on your own. And then once you have that extra practice done, go on ahead and start taking that test, okay? Good luck to you guys, and if you ever need anything, always feel free to reach out.